There's my question. Look at the difference in the adjective I'm using. This is absolute, not relative, not local. To answer this question, that is to say, to identify absolute extrema for function f over a closed interval, here's my tactic. I take my function f evaluated at the left endpoint, take my function f evaluated at the right endpoint, and take that function f and evaluate it at any critical number that lives strictly between these two endpoints. That's always going to be my approach for finding absolute extrema. Well, I hate to use the word always. There are sometimes there's some tricks I can use. So allow me. I need a derivative function to find critical numbers. So I'll pull out a nifty piece of scratch paper and differentiate. And clean up. To factor, I'll pull out another nifty piece of scratch paper. I'll use the rational root theorem. It says if this polynomial has a rational 0, it's going to be of the form p over q, where p divides evenly into the constant term and q divides evenly into the leading coefficient. So I got a lot of choices. Plus or minus 7, plus or minus 7 halves, plus or minus 1, plus or minus 1 half. So 8 choices. Here are my coefficients. I'll try -1. Isn't that wonderful? It works. So I do think the only two critical numbers I find are at -1 and positive 7 halves, both of which happen to live strictly between these two endpoints. So I'm going to try both of them. I will take my function f, evaluate the endpoints as I suggested, but also evaluate at these two critical numbers. But certainly something has gone wrong with my board space availability. And let's see if I can't generate this rather quickly. My eyes are so bad. So -1. My goodness. Now, I asked for all absolute extrema or y values, so I guess to officially answer my question, this number right here, this output, this y value, is indeed my absolute min y value, whereas this 13 is my absolute max y value, at least over that closed interval.